All right. Thanks everybody for coming out. This is actually going to be kind of a short and sweet presentation. So the presentation for tonight is going to be on the add-on API for Node.js. This is actually something I've been wanting to cover for a while, but there's been so many other things, so many other interesting topics and stuff like that we haven't really had a chance to go over it. But I figured I'd go ahead and take a stab at it at this time. So first things first, I was just going to say that we're always looking for speakers. And so if you're watching this online or you're here, if you're interested in doing a presentation, please let me know and we'll get you on the schedule. The next meeting will probably be January of next year. Just quick some facts about me. I have a YouTube channel called the Polyglot Engineer. I haven't posted a lot to it lately, but I've been trying to do some videos and stuff to kind of cover topics like these, short little things that kind of give you like an intro or show you how to take one technology and move it to another. I also have a GitHub page that I've listed here, and I also do a lot of technical, like I don't think you call it tweeting anymore. I think it's called Xing. But yeah, I have one of my handles is JaxNode for this user group, and then I have one for the Polyglot Engineer channel as well. So it's all the technical stuff that we cover here. Is like I generally will post links and stuff like that on those handles as well. So native modules. So what exactly are native modules? So I think really to kind of talk about that, you have to talk about Node.js as a whole and what you can do with Node.js. And so one of the things that's always been very powerful about Node.js is the whole module ecosystem. And so I think most people that work with Node know about NPM, the Node package manager. And there's more packages available on NPM than for any other platform or language solution. And I forget, I think it's over like I haven't even looked to see what the number is lately, but it's like pretty much you can find a module for doing just about anything. And for the most part, most of these modules and stuff are just written in JavaScript. And as a matter of fact, if you go into the source code for Node.js itself, it's made up of a lot of different modules and stuff that you can use. And so what's interesting about that is a lot of those modules are just pure JavaScript modules, but there's some of them that actually incorporate a lot of native code as well. And so you were just mentioning one of the users here was just mentioning Bun, which is another JavaScript runtime. And if you actually take a look at the Node.js runtime and project, it is a C++ project. And it has JavaScript in it, and it has the V8 engine for being able to execute the JavaScript, but it is a C++ project. And so the way that you've been able to extend it outside of the JavaScript ecosystem is by writing these native modules. And in the past, it's typically, that was either done in C or C++. But there's actually a lot of different languages that you can actually extend and use with Node.js. So this is one of my favorite laws. This is Atwood's law. And Atwood's law says that any application that can be written in JavaScript will eventually be written in JavaScript. And that's certainly true. And what's interesting about that is that one of the things that I know that I've tried to do is I've tried to do stuff like in pure JavaScript, but there's some things where, things are not just going to perform very well if you just try to do everything in JavaScript. And so I think this is one of the things that the machine learning and AI community is running into right now. So last month's presentation we did on Mojo, which essentially is that language is a superset of Python. And what's interesting about that is that one of the problems that most people that are trying to develop AI software right now are running into is that, is almost everybody starts off writing everything in Python, but then what happens is they start running into performance problems and scaling issues with using Python, and so they wind up having to rewrite parts of it using CPython, where they'll take C or C++ code and extend it so that they can use it inside of Python. So that's really not all that different from the experience that we have with the Node.js community. So why would you want to write a native module? So the main reason is going to be performance. And so you're going to be able to get a lot better performance with using native code over using pure JavaScript. And native code is almost always going to outperform Node.js because you can use statically typed languages that are compiled that have a runtime or a executable that runs directly against the CPU architecture that you're using. So you're always going to be able to get better performance. Another reason is that there's actually a lot of pre-existing code bases that are written in these native languages, and so there's a lot of stuff where one of the, I think, common examples is like, say, image processing. And so I ran into this problem myself where I had a module that I had written that would go and resize these icons to all the different sizes that Apple needs for the for the iPhone and the iPad and all that. And so I'd originally used a pure JavaScript library to do that. And it worked pretty well, but it took a little while to generate all those different icons. And so I was doing tricks where I was using like all the different CPU cores on the processor to try to parallelize as much of that as possible. But it's still you get some speed improvements, but it's like maybe I was able to cut the rendering time in half by doing that. And so I started using a blogging framework called Gatsby.js, which is a really nice like React-based blogging or static site generator. And so they have all this stuff built into it for doing the image processing. And one of the things that they did that was pretty neat was they used this library called Sharp, and Sharp is actually a C++ library for doing image processing. And so they just took that and made a node module out of that. And now, like when I took that original module I had written that was using the pure JavaScript, I think it was called GIMP, was the original one. I replaced it with Sharp. And now it's like almost instantaneous, like how quickly I can render those all those icons. So there's a lot of current trends that are happening right now. One of the trends that I'm seeing is that there's a lot of stuff that is being rewritten in Rust. And I don't know how familiar everybody here is with Rust, but one of the things is that Vercel with Next.js, they have a tool called TurboPack. They just started incorporating. There's also this tool Vite from Vue that's from the same guy that invented Vue.js. And Vercel's they're a cloud hosting company. They're looking at all kinds of ways where they can kind of speed things up and get better performance. And so the way that they're doing that is taking pre-existing JavaScript only modules, and they're rewriting them to run natively. And in most cases, they're using Rust to do that. So to talk about that, I think one of the things we have to really kind of talk about is the node internals first. So Node.js, original implementation, they're still doing this. It really incorporates two different pieces or two different libraries. And one of those libraries is V8, which is the JavaScript engine. It's the same JavaScript engine that's in the Chrome browser, now the Edge browser. Pretty much every browser out there is using V8 with the exceptions of I think Safari and Mozilla. And then the other piece is this piece called libuv, and libuv is essentially is a way that they're able to manage all the synchronous behavior. in Node.js. And so one of the things that, nice about JavaScript is it's a single threaded, language. And the whole idea is that, you can, hand something off to a callback or to a promise, and it doesn't, bog your program down. So you can say, it's like, well, this network request might take a while to come back, or this, database request might take a while, or maybe this IO processing might take some time. I'm going to basically, I just want this callback to handle the result of this promise, or maybe even a sync await to handle that. And it keeps on running this run loop. And the way it's doing that is it's using libvv to do that. And so one of the things that they do inside of Node itself is they use a combination of these two different frameworks to be able to, produce the runtime. And so if you're going to be extending Node, it is possible to take advantage of some of these internals, but it may not always be a good idea. And I'll go into that here in a second. So there's a couple different options here for doing our native add-ons. I don't even have all of them listed here, but these are some of the more common ones. And so you can create a V8 add-on with C++. You can also use the Node API add-on, which is the kind of like the official way that you can write add-on modules for Node.js. And the thing that's nice about that is they have essentially an interface that you can use for doing all the different things you need to be able to do to talk to Node.js, and it will be backwards compatible. And then you can also use the foreign function interface, or FFI. This is like very common in a lot of different runtimes and stuff. If you need to be able to interact with like a native library or something like that, they can do like an extern C as an example on a function, and then be able to call that using the foreign function interface. There's also a tool that I'm going to demo tonight called Neon, which is a Rust-based tool. And something else that you can also do is you can use WebAssembly or WASM to kind of extend it. It's not technically a pure native solution, but it may be good enough depending on what your needs are. So the tools we typically use to be able to build these, there's one that's called Node.js. And if you want to use that, you can just install that globally using the -G flag with npm install, and that'll install it for your whole system. And then when you're writing your native modules, you can use the binding.jep. There's I'll look for a binding.jep file that you can use when you're going to actually do the building and the configuring and stuff. And there's also another library you might want to make use of, which is the cmake.js. And so a lot of C++ developers have used this tool called cmake for handling all their building and stuff like that. And there's a JavaScript version of that for doing these native modules. So this is what the binding.jip file typically looks like. I actually took this out from one of my modules. And so essentially you define a target, and then the target, you can specify the name of the target. You can list your sources. You can also use includes directories. Includes directories would be for your headers. And you can also use flags as well. So then if you're going to create like a V8 add-on, this is usually written in C++. One of the problems with this is a tightly coupled solution. So that means that, if you're using, let's say, Node version 18 and they upgrade to Node 20, your module may break when they try to do the upgrade. And this has been like a very common problem with a lot of people. Some people are using modules that if they upgrade to a new version of Node, they can't, because it'll break because they have this dependency and stuff like that. And so this is one of the reasons why I would advise against doing this. But I'm going to give a demo of this so you can see what it looks like tonight. And then I think I already showed the Node.js and installing that. But once you have Node.js installed and you have your code and you want to essentially compile your native module, You use Node.js to configure and Node.js to build that. And so if you've done any C or C++ programming, stuff like that, there's make files as an example. And this is very common, this same type of thing you do with like a make file. So then there's the Node API. This is the API. If you're going to be using C or C++, this is the API you probably want to use. And so this will work between different versions of Node. And so one of the purposes of this this API, it used to be called the N API, and before that, it used to be called NAN, N-A-N, which in JavaScript also means not a number. And when they originally did that, they're almost doing it to kind of troll the users. But I think they've gotten a little bit more professional about that. Another thing that's nice about this is that when you are writing, the only header that you need to include to be able to incorporate this API is just this one header called nappy.h. And so that's another thing that's nice about this this framework. And it'll work fine with C. It'll also work with C++. We mentioned the foreign function interface before. There's actually an NPM package for being able to build these. And so if you already have, like, let's say, a pre-existing library that you want to be able to use, you can use the FFI to essentially just use that directly. So you can essentially, what you're doing here is you're just writing a wrapper with Node.js around your native library. And so in this case, it may be possible to not have to write any native code whatsoever, just use FFI to be able to do that. And this is actually something that's pretty popular, like in the Ruby world. There's a lot of use of FFI in that community. And then the only downside I'd say with this is that there's a little extra overhead with doing that. And so it's still pretty fast, but it's not going to be as fast if you're doing a direct, if you're using the NAPI as an example. And then there's Rust. And so one of the things I want to talk about tonight is one of the ideas I've had for like doing a future presentation here has been on the Rust programming language itself. I don't know if anybody here has any experience around Rust, but we use a little bit at my current company. But it's really, I think, really started to become more and more popular. And so, like, I'm always looking to see which languages and stuff that seem to be getting a lot more of the mind share. So this is a project that was really originally started a little over 10 years ago at Mozilla, and they actually do use it in Firefox. And so I think one of the rendering engines or the style sheet engine or something like that is rendered in Rust. I'm not sure. So they're already using it. But one of the ideas with the language, like one of the things you can do with C, for example, is you can write an operating system around that language. It's meant to be a language that can be a low-level language and stuff like that. And Rust, one of the ideas they have with Rust, there's always been languages that people have tried to design. It's like, well, this is going to be the replacement for C++, or this is going to be the replacement for C and stuff like that. And nine times out of 10, they never, achieve that goal. C is still, very widely used. But Rust has started to gain a lot of traction in that area. So I've read recently that parts of the window kernel were rewritten in Rust. So Microsoft has really gotten behind this as well. And the Linux kernel, parts of the Linux kernel now are actually written in Rust as well. And so those used to be like, Linux kernel used to be like a pure C thing. And now they're actually starting to use Rust to write parts of that. But on top of writing stuff for operating systems, they're starting to use a lot of this in Node as well. And so Next.js uses SWC, which is written in Rust. And they claim you can get 20 times faster performance. SWC is a tool for essentially transpiling your JavaScript code. So for instance, if you have a TypeScript file or you have a JSX file for like React, it will do all the transpiling for you, but it does it much, much faster than Babel. Babel is a not native, it's a pure JavaScript tool, and SWC is written in Rust. But if you are multi-core, multi-processor, you can actually get sometimes 60 or 70 times better performance than Babel. And so one of the things that Vercel is doing, they're the hosting company I mentioned before, is they're slowly going through and they're replacing a lot of the JavaScript tools with tools that were written in Rust. And so this is something that's becoming a lot more popular. So if you need to be able to take advantage or get these speed advantages, you can use Rust, which is a more modern language than C or C++. So I just want to add something to that. And one of the reasons why Rust has become more popular is because one of the reasons why I think people are looking to replace C is that it's very easy to write, memory bugs or have, security flaws because of like a Stack Overflow or Stack Underflow, something like that in the code. And so Rust has memory management built into it, and it also has this concept of memory ownership built into it as well. And that basically means that you can't have like a lot of dangling pointers and stuff like that in your code. The compiler will actually catch a lot of the errors and stuff before it'll let you build the application. So it's pretty powerful with a lot of stuff that you can do, and it's got it's probably I don't know if it's a simpler syntax, but it's definitely a more concise syntax. So there's a project called Neon, and Neon is a Rust-based library. And the thing that's really neat about it is that you can create a Neon project, and essentially what it's doing is it's creating a native module for you. So you can have your JavaScript and your Rust all in the same project. And the way you create that is you do npm init neon, and then you specify what you want to call your module, and then it will generate a fresh new project for you. So we'll demo that tonight as well. And then I decided to add WebAssembly in here as well. So WebAssembly is another interesting project. So there's a tool, it's called Inscription. I don't know if you guys have heard of that or not, but Inscription was a tool where somebody figured out, hey, I bet you we can get this 3D video game to run in the browser if we take this video game that was written in C++ and essentially transpile it down into, or compile it into JavaScript, but just a very simplified version of JavaScript that will run in the browser like very quickly. And so they did all kinds of optimizations they essentially were using JavaScript as kind of an assembly code for the web, which is pretty interesting because, the last thing I think when I look at JavaScript is assembly code. But once some of the people at Mozilla and some of the other companies saw that people were doing this, they were taking C++ code and then essentially transpiling it into JavaScript code, and said, well, maybe we should have a runtime like that inside of the JavaScript engines. And so about 5 years ago, it got added into V8. And so it was meant for the browser to be able to do stuff like be able to run video games and stuff that required like a lot of horsepower. But it also will run in Node because Node also uses V8. And so there's applications that they're probably very intensive that you can start taking advantage of by using a WebAssembly. And one of the things that's nice about Rust is that you can set up different targets for different CPUs and stuff like that, and then output like a debug or release versions for that. You can also target WebAssembly, and so what's nice about that is that you can actually compile your code down into like a WASM file, and then you run it in the browser or run in Node.js. And so I don't know if everybody here has heard of Blazor. It's a framework that Microsoft has been developing and making part of the set of standard tools and stuff you can use with like Visual Studio and .NET. Yeah, there's some companies that like this because you can write all of your code in C#. So if you're doing .NET development, as an example, you can have your developers write all the front-end code in C#, and then what it does is it actually creates this little WASM file that loads in the browser that does all of the front end stuff. And so what they've been able to do is they say it's like you're a C# developer and you don't want to learn JavaScript. That's fine. We have a framework that you can use called Blazor, and they're using WebAssembly to do that. So that's another option. So that I'm going to do a demo. So let me do this. So I have some projects in here. And so what I'm going to do is I'm going to go into each one so I can show each example. The first thing I'm going to do is I'm going to go into this Hello V8. And this is kind of example I would not suggest using because this would not be backwards compatible between different versions. But the way this works is if I come over here, I've got my index here and I'm just referencing, I'm going to blow this up so you guys can read it a little bit better. Is that better? Can everybody read that okay? Excuse me. So now, if I come over here, this is actually the C++. And so if you look at this, you can see here I've created this namespace for my demo. And this is actually taken directly off the Node.js docs. And so if we take a look at this, if you actually go and take a look at the internals for Node.js, one of the things you'll see quite a bit of is this isolate. And the isolate essentially is a instance of Node that you can use for executing JavaScript, as an example. And what they're doing here is they're just using this this macro here to set up a method here called hello. And then what it's doing here is it's just printing out the word. So if I come over here and I want to make a modification to this, and I'm going to say hello. And let's put this inside of brackets. There we go. And we save that. And I'm going to try running this. So let me come back out here. And so let's just do this. So I'm going to say node index. And there just printed out hello world. So there's how you can do a hello world that is written in essentially both C++ and JavaScript at the same time. So, and like I was saying before, this is not the way that you want to build this because you can see that this is referencing a lot of different namespaces and stuff like that that may change over time. So this would most likely would probably break. But anyways. That's one way that you can create an add-on. So I'm going to go ahead and close that. And let's take a look at the next example. This next one here is one that's using the Node API. All right. Okay. So this one looks very similar. The main difference here is that if we take a look at my binding.zip file here, what I'm doing here is I'm actually importing my headers here from this this Node API, Node add-on API. And this is actually a kind of like an additional framework. It's not in the official, what is part of the official Node.js release, but it's not, doesn't come automatically. You have to install it as an NPM package, but it's meant for making it a little bit easier for writing C++. So the Node API is essentially, it's a C-based set of functions and stuff that you can use. But if you use this this NPM package here, you can actually use this with C++. And so I'm just going to close this here, make this a little bit easier to read. So in this example here, this is actually using the NAPI header here. And then what I'm doing here is I have an environment that I'm setting that's coming from, it's coming into this, or we're creating an environment here with this method here. And then in the init for this, what we're doing here is that we're exporting out this this function here, and it's taking that environment, and then we'll use this Node API module. And so what this will do is I'll take this method and I'll make it available as a function called hello inside of our JavaScript. So if we come back out here and take a look at this, here's our hello. And so let me see, take a look at the npm scripts. Didn't have that. So I'm just going to come here and I'm going to do node jip or gup. Let's see if that works. All right. And now I should be able to node, and then voila. Now we have our little hello from Jack's Node C++. And so if you're going to use C++, this is the way I'd recommend using it. There's a whole bunch of stuff in here, and so I didn't want to cover the whole NAPI API, and I didn't want to cover the whole language, but I just show that it's pretty easy to create a function and then add it into Node. It's a native function. All right, so let me kill that. And let's come back out here. And what we got here? So the other thing I want to show is I want to show an example of Sharp. So we go and take a look at this. And that's getting a little bit longer, but this actually has a C, or basically a shared object that it's using. So if I come into here, an example, so here I have I'm importing in this the Sharp library. And if we go and open that up, and we come in here, find Sharp. There we go. All right. So we can hear that it's including all these different sources here for the connection, but it's this is a nice example of how you can configure use the binding.jip. And then if we go here and take a look at a source, we can see we've got all the different sources in here. But I thought they had. I'm trying to think. I thought I was looking for some more JavaScript stuff. There are some JavaScript-based references here. But you can see that this is all, this is all C++ code. And they're just basically extending this stuff out using C++ and then using it here. But, just as an example here, it's like, last month's presentation, one of the things that's neat about Mojo is that, they have direct access to the SIMD, right? And here you can use all those same SIMD functions and stuff using, if you're just using C++. So I want to show this as a quick example, but this is all used in the NAPI functions, just like in the previous example that we saw. All right. And so for the last thing here, I'm going to go into this Rust module. I'm not so sure why it's taking so long to open up this file here. All right. Anyways, I've done very little Rust, by no means a Rust expert, but I decided to go through here and to see if I could write write a Neon-based module here. And so when you go to create a new Neon module by default, I believe it comes or it'll come running this this hello function or something similar to this. But as you can see here, the way that you create a function or you define a function in Rust is you use the fn keyword. And so what I find funny about this is that the function keyword is a very common keyword in a lot of different languages. And so in JavaScript, it was just called function. And then in languages like Swift, they trimmed it down to where it's just func, F-U-N-C. And then if you're using Kotlin, they change it to just being fun, F-U-N, fun for function. And now with Rust, it's just FN, and whatever next language that comes along, they'll probably just use F. But I hope not. So anyways, they have a function context that gets passed in here. And then it outputs a JavaScript-based result, and this result is going to be based off the JS string. And you can use they're using a template syntax or generic syntax like that's popular in a lot of other languages, like C# and Java both have a generic syntax. And then they're using a kind of like almost like a promise they're doing okay to output the results. One of the things that's interesting about Rust is that you don't have to do a return for your output. So you're allowed to use a return for outputting that, but once you do that, you have to put a semicolon at the end of it. And one of the things that's interesting about Rust is that it'll look at the last line in your function and just assume, if you don't have a return statement, that you're supposed to be returning that as the result. So that's what they're doing here. And I have another function here that just this is pretty simple. It's just adding two numbers together, and it's just pulling the arguments. It's assuming this is coming from JavaScript because they're using the function context here. And then I'm just taking the first argument, the second argument here, assigning them these values. And then once I've done that, I'm going to set those values to a floating point or 64-bit floating point value. I'm going to add those two values together, and then I'm going to output them back out as a JavaScript result. And here the result set is I'm using JS number for the result set. And then I have another here. This is another example. I decided to do a Fibonacci function because that's always a good example of like something that's not performant. Something that's also nice about Neon is that when you gen a project with this, it comes with all the tooling and stuff already built in for being able to compile everything. So I can come over here, hit build, and it'll go through and it'll build this this module out. All right, and let's take a look at these tests that I've written here. So I have one test in here that is using the add two numbers. So you can see here, all I have to do to bring this in is to use the require statement, and that puts it into this this variable here called the Rust module. And then any of the functions that I've exported will automatically be assigned to that to this Rust module. And so I have one here that's using to add two numbers together. So I'm just going to run that. And we can see here that it's adding these two numbers together here, but it's also doing Fibonacci. So we go down here. Just as a comparison, I decided to run the Fibonacci against both of these. So I'm going to run this from the terminal here. Excuse me. So I'm gonna say npm JS text. So I don't know if you saw that or not, but the JavaScript version of Fibonacci, and there's a bug in my code. I'm going to fix that here real quick. But the JavaScript version of that, you could see that it took a little while to be able to generate that number out from the Fibonacci function. But it was very, very quick when we did it with Rust. So I'm going to come back here, see if I can't fix my bug. So there's nothing like doing a little live coding here. I think I see the problem. All right, let me fix that. And I'm gonna try running that again. So you can see the Rust one ran almost instantaneously. So it's able to obviously run, much, much faster than I'd be able to use the V8 engine to be able to generate that result. So those were my demos. Just going to add something to that as far as I didn't have a demo for WebAssembly, but with Rust you can just add a target for doing WebAssembly, and then you can incorporate that WASM into your application and get similar speed performances. So that was what I wanted to demo. So any questions? No questions? What did everybody think of Rust? Yes, yeah, and it's because essentially you're able to compile code that'll run right against the type of processor that you have, and get all the speed advantages and stuff. And something else that's interesting about Rust is built with is from the LLVM compiler architecture, which is the same architecture that's used with Clang. It's also the same architecture that Apple uses for all their stuff. Swift uses that same compiler technology, and they're able to do some pretty neat stuff with that. And one of the things that they can do now, and they're doing this with Mojo, is they use a thing called the MLIR, and they're able to target not just the CPU architecture, but they can also target any specialized hardware. So if you're using field programmable gate arrays as an example, you'll be able to compile code and run that against that. They can do that with Mojo. And the same thing about GPUs. And so one of the ways that they're speeding up machine learning and AI applications is that they're using SIMD, and they're able to use NVIDIA GPUs as an example. That's something a trick they were using for a long time. It's like NVIDIA was smart, and they realized that the same type of math that's excellent for doing video games is the same kind of math that's actually excellent for doing machine learning and artificial intelligence. And so they came out with these CUDA libraries, and where you could kind of it gave you an interface to be able to use their cards in order to take advantage of their GPU architecture to execute all this linear algebra much faster than you'd be able to do if you're just using the CPU. And so that's where a lot of the speed advantages and stuff can come from. If you're able to take advantage of that specialized hardware, you can get stuff that it's screamingly fast. So yeah, Rust is I don't know how much Rust is taking advantage of that, but Rust is using that same engine. And there's a lot of newer features that are nice, like for instance, if you're using .NET or JavaScript for that matter, you can use async and await, which will allow you essentially to do asynchronous functions, but as a single function. And you can use async and await in Rust as well. And so they've simplified a lot of the stuff for doing synchronous code. And I don't know, people find that easier than I forget the way that you can do that in Go, but I think Rust is I don't think it's as easy language to learn as Go, but I think it's probably better for doing lower level programming than Go. But that's just my opinion. But anyways, I thought it was interesting. It's one of those languages it's on my list of things to learn and stuff like that. And so I thought this might be a good chance to get some exposure to Rust. There's a tool internally at my company where we use Rust, and I want to write a plugin for it. And so it says like, well, you don't have to do it in Rust; it can be in any language. But so I kind of like to do it in Rust just because the tool itself was written in Rust. So I'm trying to think if I had anything else to do, but anyways, that's just kind of a basic introduction to the NAPI and WebAssembly and Neon, some of these other tools for doing that. So if you need to be able to take advantage of, if you need to get, really fast, or better performance and stuff out of your Node applications, you can do that. And a lot of the tooling is kind of heading that way now with like Next. And so they have this tool, it's built in here. I think I have it up. I might have closed it, but all the stuff, especially with with Node.js, this is all fairly well documented. The stuff that's specific for C++, if you want to use NAPI of C++, that's not on their documentation page here, but it is in the GitHub repo. So they have a GitHub repo that has all that stuff. And then Neon's actually, I think, pretty simple and stuff. So they have all the different examples and stuff on the neonbindings.com website. That's all there. And I'll put the links to all this stuff up on the Meetup site and the Slack site as well. All right. Well, that is all I had. Thanks everybody for coming out tonight. And since we won't be meeting again this year, I will see everybody next year. All right. Thanks.